Now we'll get started with the labs. So we are working on lab 2. And just to remind you all, when working with Jupyter Notebook, you need to know where the file is stored. So for me, this is where I put the .ipynb files, which is interactive Python notebook. So again, can you just double click this and open it? No. Do you just open it with a browser after it's downloaded? No. It has to be opened with Jupyter Notebook. That's why it's interactive Python notebook. So there is no easy way to right click and open it with Jupyter Notebook or something. You have to open Jupyter Notebook first. So a couple of you had questions about that. So how do you open Jupyter Notebook? You go to your search window and you search for Anaconda, right? Anaconda Navigator. And then you click on Anaconda Navigator and what's going on here? And then it opens up Anaconda Navigator. And then you find Jupyter Notebook here and you launch Jupyter Notebook because the file you're trying to open is an interactive Python notebook. So you'll launch Jupyter Notebook first, and then because I know where I put the file, you navigate to where you put your file. Typically you will put it on your downloads, but you just need to know the location and then go to where the file is using this browser in Jupyter Notebook. So this will be the root, and then from here you can find your documents or downloads, and then you can go to the folder that has your file. These are my files, and today we'll be looking at lab 2 data type. So this is what you need to know before you can work on lab 2 workbook. So we're going to be talking about different data types in Python. So these data types are common in virtually any programming language for that matter. So we have integers, right? I'm going to focus on the most important to us, right? There are some other data types that we are not going to be using, and I wouldn't talk much about that so we don't get distracted. Let's focus on what we actually need. So integer is one of the data types, and you know what integers are, right? These are whole numbers: 1, 2, 3, 4, even -1. Negative values are also integers. So here I'm setting I to 3. Remember, Python is dynamically typed, so you don't need to define the data type of the value before you store it into it. So I is able to figure out it's an integer from the value you store in it. So if you store 3.5 in it, like we do here, we store 3.2 in Y1, we store 5,100, right? That's what 5.1E3 is into Y2. It will see those as real numbers, right? So the data type will be floating point numbers. So let's get started with this one. There is a type function in Python, and you can use the type function to figure out the data type of any object in Python. So I run this first one by clicking on run or control enter on Windows, and then it tells you that the type is integer. A few of you had questions about these cells. If you want to do something else, you want to practice while working on these these workbooks, just click on this plus here and it will create a new cell wherever you had clicked on. So if you have clicked on this one, so this cell is selected, when you do plus, it's going to put it below the selected cell. So here you can actually program and test different things. You can test putting a different value, storing a different value into J, and then you can print J, right? And then do control enter, and then print J as 7. It knows it is an integer. So find the type It tells you what type it is. It's a good idea to use variables named from I, J, K, single letter variables to store integers. And then for real numbers, you can store them in variables that indicate what they are, like oil density or viscosity. Then you store the viscosity value, like we talked about good naming conventions. This, we already talked about this in lab 1, right? Where if you separate values by comma, you can also separate the variable names by comma, and then it will assign to 3.2 to the first variable y1, 5.1 e3, which is 5.1 times 10 raised to power 3. That's what this e3 is. So it's double, and it's going to be 5100, but it's going to be double because of the decimal place here. So it's floating point precision numbers. Remember the F formatted strings. Throughout this course, it will be a good idea if you master these F formatted strings and you only focus on using that. You don't need to spend more time trying out different print statements. This is the most robust. You put, again, with this cell selected, I can click on the plus sign so it gives me an empty cell. And again, the way to think about it is write your print function, open and close it. You know you're gonna need some quotes. It can either be single or double quotes. You see the way I program, I open and close parentheses, I open and close quotes. Then whatever I want to type will be in here, right? Then you put F outside. So it's a formatted print statement. And then you can say whatever you want. Type of Y1 is then what you want to be printed, which is a Python code. It has to be in a curly parenthesis. So you can do Y1. And then it will tell you the type of Y1. So do this. And once you master this, it's going to be very easy for you. So both Y1 and Y2 are of type floats. Boolean. So there's Boolean data type, which is true or false, right? So you can type true, starting with a capital T, and store it into a Boolean data type. It's used for logic. So you want a certain calculation to be done if a condition is true. That's a logical, we'll talk about logical, we already talked about logical operators like greater than, equal to, and, not. Well, this data type works with those a lot. So true is a Boolean data type, false is another data type, and then you can use the type to figure out what it is, and it tells you it's bool for Boolean. So this could have been anything, right? You could have made this XXX, but it's not a good variable name, right? So if you print XXX, yeah, it will be Boolean. No difference. But in a month's time, it will be difficult to know what you stored in X. But if you had labeled it like so, because the variable name already indicates it's Boolean, it helps you remember. It helps others remember too when you share your code with other collaborators. So I love to use variable names like is integer or is whatever, so that it shows that the answer to that will be true or false, and then that will indicate the data type. So good programming practice to label your variables such that it's easy to infer what is stored in them. There is also binary, which I provide here for completeness, but we wouldn't talk about that beyond this point. There is also complex numbers. We don't do that in we don't do calculations on complex numbers in petroleum engineering that much, so I wouldn't talk about it. So it's just provided for completeness. This is very important. You need to be able to convert from one data type to the other. So to convert from float, right? That's what 3.3 is. It's a real number because it has a decimal place. We want to convert it to an integer. Then use the int command as a function. So, and that's the data, that's the standard form for doing conversion. So if you want to convert a number from whatever data type to integer, provide that number or variable inside this int function. If you want to convert to a real number, you use the float function, and then the number will be inside this. It could be a variable, it will be inside this parenthesis. And that's the general way to move from one data type to the other. If you want to convert to string, no. Let's try it out. That's one thing about computer programming. You can always try it out. You don't have to remember everything by heart. Once you have the general idea of the function, you can try it out, run it, and if it doesn't work, then you know. So string is not defined. That's not how you convert to string. You don't typecast to string that way. So let's not jump ahead of ourselves. We'll get to strings later. Integers and floats are the first ones we've talked about. The first data types. So you can provide a number, you can provide an integer. So the first one will convert 5.55 to 6 because it rounds it off as an integer. Then the next one, float, will convert 5 to 5.0, so real number. And that's what you see here. If you wanted to see the first one, you can either use a print statement or just, the last line in your cell typically will print out to this window. So here you see it actually doesn't round off. So int just picks the integer part and ignores the decimal place, so it doesn't round up. So even if this is 5.999, it doesn't round up. It just grabs the integer part and ignores the decimal part. And float will take a number and then just append zeros to the decimal places. You can do float on this, it's already a floating point, right? But more importantly, you can typecast. You can cast 5 from an integer into a floating point number. Good, we keep moving. So I already explained all of that, right? These doesn't have to be actual values. It could be x, right? Where x is a variable, and that's what's going on here. So you're passing in variables into those functions. So float will convert whatever variable this is to a real number, a floating point precision number. This will do the opposite, convert to integers. And then always use F formatted strings so that you can write useful text while printing out results. So this will say x equals whatever the value of x is, j will be equal whatever the value of j is, and their data types, and it prints it out. And we can actually run this. So x is 3. I've deleted some things, but x was set to 3 previously. And then you see the informative printout statements from using F formatted strings. Complex numbers, again, we're not going to talk about it. It's there for completeness. This is very important. We'll be using this a lot in the programming assignments, in your lab workbooks, and in your exams. So it's important to be able to read a value from Python and then do calculations with it. So let's do it from scratch. So important to note that in the standard approach to read, all you need to do is to use the input function. So input open and close parentheses. This is what reads. And now, to inform the user on what you're trying to do, you can say enter your name. Instead of it just blinking and asking for value and you don't know what it's asking, this will say enter your name when you run it. So if I run this, it says enter your name, and then you can put your name in there, and then hopefully your code does something with it. If you don't do anything, just provide the input function and you run it, then it's just a blank stuff. You don't know what it's asking you for. So someone could put in an integer, someone could put in a floating point number, someone could put in a string. So that's the first thing. Always good to give an informative text. So this will say enter a value between 0 and 100, and now if I enter a value, what happens? It stores whatever you entered into score string. So now you can do something with core string, right? You can print it out. Where's my mouse? I don't see my mouse anymore, and this is a good time to pause the video and we'll continue from there.